Welcome back to our series, Design Patterns. In episode 1, we covered the singleton pattern, a way to ensure only one instance of a class exists. Today in episode 2, we're moving on to a pattern that tackles another fundamental problem in software design, object creation. Ever found yourself writing huge constructors or using if-else or switch statements to decide which object to create? That's a red flag. Instead, we can use the factory method pattern, a powerful creational pattern that puts the responsibility of object creation into subclasses. So what actually is it? The factory method defines an interface for creating an object, but lets subclasses decide which class to instantiate. It promotes loose coupling by eliminating the need to bind application-specific classes into your code. In other words, you program to an interface, not an implementation. And some use cases might be frameworks and libraries that need to delegate object creation when the type of object to be created depends on some configuration or user input, GUI components, or cross-platform renderers. Let's say we have an application that can send notifications either via email or SMS. We want to encapsulate that logic of creating these objects. So first of all, what we need is a shared interface. And now I need to become small so you can actually read the code. Bam. All right. So we need to create a notification interface, right? We have a notification that says notify user. That's the interface that we're programming against, right? Now we need two concrete implementations of this interface. The first is email notification. It implements notification, and for now all it does is print sending an email notification. Wow, amazing. Now we can go to SMS notification. We do the same thing. We implement the notification, we create SMS notification, and this one prints sending an SMS notification. Now we need to create the factory class. So we create an abstract notification factory, which has a create notification method. All right, you're with me? Let's go to the next one. And we need to create two concrete factories. All right, we have the SMS notification factory, which returns a new SMS notification. And we have a email notification factory, which creates a email notification. All right. Now we go on to the next one. We have a notification surface or main. Let's just say we can call this notification surface, but I just called it main for this example. Now this is a channel. The channel could be dynamic based on input or configuration of a user. We have a notification factory, right? And we check what the user input is. So if it is a SMS, then we create an SMS factory. And if it is an email, we'll create an email factory, which will create emails and abstract away all of the stuff that we actually need to do. This can change. So it could be email, it could be SMS. And in the future, we can add as many as we want. Now, we have created a notification factory, which is the abstract class, right? We have create notification. And that's all that we need to know. Now here, if we look, we have said that we have a concrete SMS notification factory, which adheres to the abstract notification factory, right? So we have that for SMS, we have that for email. And now all we have to do here is we can call on the same stuff without knowing any of the implementation. We don't know what we're sending here. We don't know if it's an SMS, an email, a letter, a pigeon. It could be anything, right? We just call create a notification, which is what we do here, create notification. And what we do here is we say notify user, and it just sends that notification to that user. That's all it does. It's not that hard, but the key benefits of this is encapsulation of object creation. The logic of creating all of these objects is abstracted away here. We have an email notification, and here we create, that's an email notification and an SMS notification, and we make all of these objects here. Now, you might think like, oh, John, this is really a simple stuff, and I can just create like two separate notifications. You could, but just imagine creating in a huge code base and then having to create very specific classes, it gets messy really, really fast. So in that case, you might want to use this solution and this design pattern. So we also use the open-closed principle. We can add new types without changing existing code. We can just add a new type right here, and we have added a new type without changing any of this code, any of this creation of code. And we have ease of testing. You can inject mock factories or stop notifications and just easily test everything that you want to test. It's also an anti-pattern. In beginner code bases, you often see the new keywords scattered all over. This makes the app hard to test, hard to extend, and very tightly coupled. The factory method fixes this by centralizing and abstracting creation logic. Well, there's also some cases where you don't want to use it. If you only have one implementation, maybe two, like this, a factory might be overkill. But if you have to create like 15 or 10 or 8 very complex classes, then it's useful. If object creation is simple and doesn't vary, stick to direct instantiation, it's better. But if it's complex objects that you need to create, and if you have to do that a lot of times, then this is what you need. Some best practices: use interfaces for products or anything else, like notification. We've used notification right here, and we have email notification, SMS notification. So everything is a notification. Use abstract classes or interfaces for factories, like we did here. We have an abstract notification factory, and then we have notification factory which extends email notification factory, which extends notification factory, right? Use naming conventions like factory to make your code base intuitive. A lot of people know what a factory is, especially if you work in Java. It's used a lot in Java code bases, so everybody knows what a factory is. Don't call it creator or something else. Just stick with factory. That's what everybody knows, and it's ease of use for new programmers or existing programmers on your project. Avoid logic inside the concrete products. Keep behavior polymorphic. All right. Don't put a lot of logic into your concrete products. Okay. Today, we implemented the factory method pattern in Java using a notification system as our example. We saw how this pattern helps decouple creation logic from usage, making code more flexible and easier to maintain. In the next episode, we'll build on this concept with the abstract factory pattern, where we deal with families of related objects, not just one type. Make sure to like, subscribe, and share this with fellow Java devs. Have a great day. See you in the next episode, and happy programming.